So our last type of equation that we need to solve for a 10.6 are equations that have fractional exponents. But recall what a fractional exponent means, right? If we're looking at x to the 1/2, that just means we're looking at the square root of x. So I think you know where this is coming. So what we're going to basically do for these equations that have radicals in them is we're just going to convert them to their radical form. And then once we have that in that radical form, we can just do what we just did in the last videos. We can solve it as a radical. So I'm actually going to do this one first. I realize there's a little bit more going on in that one that I'll come back to. But for here, we have x minus 2 to the 1/3 power. So the parentheses tell me that the x minus 2 is the entire radical. That 3 where it's at tells me that that's the index, and we're raising it to the power of 1. So we're basically looking at the cube root of x minus 2, and it's equal to 3. Now it's pretty easy, right? We know to get rid of that radical, I have to raise each side to the 3rd power. Radical gets cleared. 3 cubed is 27. Add 2 to both sides, and we get x equals, it looks like 29 in that case. Pretty easy to check, right? Because when I put 29 in there, 29 minus 2 is 27. The cube root of 27 is 3. So that is our solution. So there's our trick. There's our idea. So in the next one, like I said, there's a little more going on here. The parentheses are telling me that the x minus 5 is under the radical. The 2 where it's at tells me that it's a square root, and that 3 where it's at is basically telling me is that we are cubing it. And I'm going to choose to put the cube root inside. As we've seen, that power can go outside or inside, but I'm going to choose to put it inside. Again, you can do what you want. It doesn't really matter. It just kind of changes the sequence of events that comes forward. So there we have it. So our first move then is we want to clear this radical. So we have a square root, so I clear it by squaring both sides. What I'm going to be left with over here is x minus 5 to the 3rd power, and 8 squared is 64. Okay, so far so good. But now what we have is we have a power of 3. So we've seen quite frequently where we're getting rid of radicals by raising it to a power. Well, I can get rid of a power by applying the proper root. And in this case, since I have a cubed root, since I have a cube, we're going to take advantage of a cubed root. But whatever I do to one side, I have to make sure I do the same thing to the other. So my powers are the same. My power matches the index. So we have x minus 5, and I believe the cube root of 64 is 4. Add 5 to both sides, and there is our solution. Of course, to check it, 9 times 5 is 64. 9 minus 5 is 4. And then we can think of this as the square root of 4 to the 3rd power. So the square root of 4 is 2, and if I raise it to the 3rd power, I get 8. So it checks out real nicely. All right, so that's kind of how you handle those tougher ones. So you basically kind of have to do a power to get rid of a radical, and then you have to apply a radical to get rid of a power. All right, so we're kind of doing both there. Last but not least, over here we have 2 fractional exponents. So we're basically looking at the square root of x, and that's going to be plus the square root of x minus 24 equals 2. So we essentially have an equation with 2 radicals in it. So what do? We isolated one and just went through our work. So I think here, how about we subtract that guy, and we get the square root of x minus 24 equals 2 minus the square root of x. To get rid of this radical, I will square it. And whatever I do to one side, I have to do the other. So we end up with x minus 24. And over here, again, you have to be careful because we are squaring a difference. So we have to FOIL it out, basically. So we have x minus 24. If I do my FOIL, 2 times 2 is 4. Do my outer, we have a negative 2 square root of x. Do my inner, we have another negative 2 square root of x. And then last times last, a negative times a negative is a positive, and then we're going to get x, the square root of x squared, which is just x. So we have x minus 24, that's 4 plus x, and then these two combine up to give us negative 4 square root of x. So we're sitting pretty good. Got to isolate this radical, so I'll do that by subtracting x and subtracting 4. I believe what that gets us here is a negative 28 equals a negative 4 square root of x. I'll go ahead and do this division because everything is nice. We end up getting 7 equals the square root of x. Square both sides, and it looks like we get x equals 49. So again, oops, I shouldn't circle it because we still got to go check it. When I check it in this equation, we get the square root of 49 plus, if you take 49 and take away 24, I believe you end up with 25. And so we end up with 7, right, plus 5. And does that equal 2? Unfortunately, it does not. So that is an extraneous solution. So all that hard work, and we don't even end up with the solution we need. All right, so this actually means that there is no solution because the only one we got didn't even work. So, right, how depressing, all that work, but I guess it builds some character. Okay, so you guys can slap me later if you want. But that should conclude our 10.6. We're on an upward. We're going to look at some applications in 10.7. Again, if you need help, please reach for it. Ask for Google Meet time. Jump on Canvas and show your work where we can make comments on it. Lots of places to get the help that you need. All right, you guys keep working hard.